Welcome to part 4, the last portion of the drive system videos that we're going to be working on right now. There's obviously a lot more that could be done, but I want to move on to other things which involve classes and working with classes. So we're going to just look at a few things that are useful to know when you're doing programming. Among them, I'll bring back the issue of inner classes. We'll talk about overloading methods and also have some fun with the for loops. So I hope you enjoy this and learn lots. In this section, we're just going to wrap up the drive system. Right now, we've created this drive system. We've got these 4 motors. We've initialized them at some level. And yet, this drive system is a brick. It's not going to go anywhere. It can't go anywhere because the only way for it to go anywhere is for power to be set on the motors themselves. And we have not opened up a door in our encapsulation to allow anyone to set the speed, or in this case, set the motor power. So we're going to do that now. And in the process, we're going to look at a couple things that will help us to learn about overloaded methods as well as inner classes. So the first thing we're obviously going to do is we're going to create a setter method. Public void set drive motors power. Tells you what it does. We're going to need 2 things because even though we have 4 motors, conceptually, we really only have a right side and a left side. That's all people are really going to care about. So what we're going to do is take 2 doubles in. One is going to be right side motor power. The other is going to be left side motor power. Fairly straightforward. Now, just like we did before, we're going to go up here and we're going to create some class level variables. They're going to be doubles, obviously, because they're the motor power. The drive motor right power and the private double M drive motor left power. That means we can access them throughout this entire class. And we're going to go down here and we're going to set the drive motor right power to right side motor power. And we're obviously going to do motor left power to left side motor power. So now we've enabled those, private variables, but it's still a brick because we haven't set the power. So the solution is to reach out to the drive motor right front and use the set power method on it to set it to the M drive right motor power. Same with the right rear. This should be pretty straightforward and pretty obvious to you at this point. And once we're done with this, if somebody calls our now public method, set drive motors power, and passes the doubles for the right and the left side motors power, then this brick will actually start to move. So that's well and good. Well, we have a setter. We may as well put in a getter. But the problem is, because we are actually passing in 2 parameters, we can only get 1 object at a time. So we're going to have to do a get right side motor power, which is going to obviously return the M drive right motor power. Remember, we're using class level variables. And then we're also going to have another method, public double get left side motor power. That's pretty straightforward. Hopefully this is not going to shock anyone as they look at this. But here's the thing that could be a problem. The set power is theoretically going to be between negative 1.0 and 1.0. It shouldn't be lower than negative 1.0. It shouldn't be higher than 1.0. But what if somebody passes us parameters that are outside that range? You could potentially do some damage, throw an error with our motor. So what we're going to do, or what we're going to need to do, is we're going to need to validate the parameters passed in, and we're actually going to bracket them. We're going to limit them so they can't be more than 1.0 and they can't be less than negative 1.0. So in order to accomplish this, we're going to, first of all, I'll do an example with the math min and math max. So if I say the M driver motor is going to be math.min 1.0 and right side power motor, what it does is it chooses the lesser of the two. In other words, if right side motor's power is greater than 1, it's going to choose 1. And if it's less than 1, it will choose the right side motor power. Well, that's great. What do we do for the maximum, the negative 1? Math max negative 1, only this time we're actually passing in M drive motor right power because we've already washed that. So this will prevent it from being more than 1.0, and it will prevent it from being less than negative 1.0. Now, if you guys are familiar with algebra, you know substitution systems. So M drive right motor there is the same as M drive right motor there. We can actually pass in this section. So we're going to pass this section in to the second column. And what that will do is it will actually make this single call prevent it from going higher than 1.0 or less than negative 1.0. So we've combined math max and math min, but it's very easy sometimes to get those confused. There's a better way to do this, just in terms of appearance and less chance of problem, and that is actually to use a thing called range. Range.clip says if you give me a number and you give me 2 parameters, I'll put it between them, a minimum and a maximum. So for the left power, we're going to demonstrate this. We're going to pass in the left side motor power, and we're going to say the minimum has to be negative 1.0 and the maximum 1.0. See how much nicer that looks and how more obvious that is than the math min, math max. We're going to leave the M drive motor right power the way it is just so you can see it, but the range clip is definitely a better way to go. All right, what if we wanted to actually have a getter method called get drive motors power that would return both the right and left powers? What object, what thing should it return? It could return an array of double, just 2 objects in an array of double, but that's not really the best way to go. In this case, it actually makes more sense to return a class. And we're going to create an inner class called drive motors power, which is an inner class within the external class drive system. So down at the very bottom, I'm going to create a public class drive motors power. Public means that it can be accessed from outside of this system, outside of this class. And once I've created that, I could simply say I'm going to return a new drive motors power, and that's great, except for the fact that, of course, it's not returning what I want, it's just returning an empty shell. So we need to have 2 properties. This is how we're going to do it just as a demo. Public double right side drive motors power, and also public. Notice the key public here. That means outside you can see these properties and interact with them. Public double left side drive motors power. So that's great, and I could actually, just assign them up there. But what I really want to do, since I'm going to always have both of them together, is I want to actually create an instantiation code for this inner class. And the instantiation code is going to take 2 doubles, right side drive motors power and left side drive motors power, and it's going to use them to assign the properties right side motors power and left side. Now, if you notice, the property and the parameter have exactly the same name. That can be very confusing. One of the simplest ways to distinguish between them is using the keyword this. This refers to this class. So when I use this dot right side drive motors power, I'm referring to the property, not the parameter. When I assign it to the right side drive motor power second, the code is smart enough to realize that what I want to do is assign the parameter value to the property value. And now all I need to do up here for this public getter is return a drive motors power and assign it the class level variables of M drive right motor power and M drive motor left power. So that's pretty sweet. But I want to go beyond that at this point. So I don't want anybody, once I've created that, I don't want anybody to mess with it. I want them to instantiate it and then make it untouchable. And accomplish that by the keyword final in front of the properties. This is a way to make these properties sort of read-only. Once it is created, it cannot be changed. So, for example, I'm creating a new variable k, new drive motors power, and I'm assigning it both of those things. And then I decide I want to actually change k's left side drive motors power. So I'm going to assign it to 1.0. You notice that I cannot do that. I cannot do that because in the class drive motors power, I set those properties to final. This is a way to make properties read-only. Generally, Java prefers just using getters, but this is a way to use properties, and I wanted to expose it to you. All right, so we've got this, and you may say, well, that's nice. When are we going to use it? Well, I'll give you two examples. One of which is we're going to overload the method setDriveMotorPower. But instead of accepting doubles, we're actually going to accept a single parameter called driveMotorsPower, which is of the type driveMotorPower. And then I'm going to actually, believe it or not, I'm going to call the method above. I'm going to call the setDriveMotorsPower, and I'm going to pass in two doubles. Effectively, what I've done is I have called the same method in two different ways. You can actually overload methods, give them exactly the same name, but they have to have the different parameters. I could not create another setDriveMotorsPower with a double parameter. It would just reject it because the computer wouldn't know which one to use. But because the parameters passed in are different, I can actually call this in two different ways and end up with the same thing. And because my second one is calling the first one, it's going to do exactly the same thing. So here's another great example of using the inner class and how it can be useful. Let's say I've got, and this is just stuff I've mocked up for you, I've got dance mode as my one of my linear op mode. And so what I'm going to do is I'm actually going to create an array called dance moves of drive system drive motors power. And I'm going to add in a number of drive motors powers in there. So the first one is 1 and 1. Now notice I have to do dance drive system dot new drive motors powers. That's because drive motors powers is an inner class of the drive system. So I've instantiated the drive system as dance drive system, and then I have to do a dot new drive motors power to actually load in the drive motors power inner class. So I have to call on the already instantiated outer class to then instantiate the inner class. If you do this, your helpful IDE will possibly tell you that you might want to make these static classes. If you remember from previously, static classes are classes which don't have to be instantiated because they just are. There's only one of them. And there are other limitations on static classes. So I'm not actually interested in making drive system a static class. And I'm definitely not interested in making drive motors power a system class, because then every time I changed it, I would be changing the one drive motors power. And I want to have, in this case, a half a dozen of them. So we've gone through and we've created these. It's going to go forward, it's going to turn to the left and to the right, I think it is, and a little bit more, then it's going to spin, and then it's going to go backwards. Not the most exciting of dance moves, but I'm pretty proud of our robot. So this is where, especially in autonomous mode, this could be very useful. What we're going to do is we're going to use a for loop to loop through all of these. And that means that basically it is going to go do the dance for you. So for int I equals 0, again, should be familiar from a previous video. I is less than dancemoves.length, semicolon I plus plus, and in the squirrely brackets, what we're going to do is we're going to call on the dance drive system, set drive motor power, and we're going to pass in the dance moves bracket I. And that's all we have to do. That's the beauty of setting it up as a class, because the right and the left are going to be hooked together. And this enables us to actually pass a single object rather than multiple parameters. So what if, let's say, we didn't want to start from 0? We've always started from 0 in the for loops. But what if we wanted to start in the second slot. 0, 1, 2. We want to do 3, 4, 5. Those are the ones we want to run. Well, it should be hopefully no shock to you that we can actually start I at 2. If we start I at 2 and do the exact same thing, dancemoves.length, semicolon I++, and then the squirrely brackets for the dance drive system dot set drive motors, it will actually start at slot 2, or the third one down, and it will continue from there. So the first thing it will do is it will turn to the right. So here's another thought that you may not know. For loops don't only have to go forward. Let's say we want to dance backwards. In this case, we actually have to start with dance moves.length -1. In other words, we have to start with 5. Because remember, even though there's 6 total length, it's slot 5 that we start with. In this case, we want I is greater than or equal to 0, and we do I minus minus. As you can probably guess, I minus minus is like the opposite of I plus plus. It's I equals I minus 1. We call the exact same command, dance drive system.set drive motor power dance moves bracket I, and now instead of dancing forward, we've got our little robot dancing backwards. Well, I hope this helped you understand some of the basics of programming in Java. And as we go forward, we're going to look at a number of other things, very importantly, tying in all the other bits and pieces together. As Bob Ross might say, there are no bugs, only happy accidents. So next time.